Hello, my dear friends. Anyone is in live? Anyone is in live? Good evening. Good evening, Akshara. Good evening. Good evening, Amit Dubey. Good evening, Akshara. Good evening, Amit Dubey. Rest any other? Good evening, Ajit. Good evening, Sai Vaishnavi. Good evening, Suraj. Good evening, Lasya. Good evening, Guru Sai Charan. Right. Good evening, Ashwant. Good evening. Right. Right. Now, right. Now, my dear friends, now I will give you only one suggestion for you that if you know the answer, good evening, Srinitya. Good evening, Singh. Good evening, good evening. Good evening, Sai Kirtan. Good evening, good evening, Ketan. Good evening, Ketan. My dear friends, when the question has been displayed, if you know the answer, try to say. If you don't know, just give me the question mark and don't extend. What I'm saying, don't extend more than 1.5 minute. Sorry, 1.5 second or 1.5 minute you can take. You can take it as almost 90 seconds. Okay, each question don't exceeds more than 90 seconds. I will check the time here. After giving the one question, I will wait it for the 90 to 2 minutes or 1 minute I will wait, and after that what I will do, I will itself I will explain. Okay, because in the less time we have to cover the more number of questions, so don't lag it. Good evening, Joshita. Good evening, Rishita. What? Rishita. Good evening, Subhana. Good evening. Okay, my dear friends, once again, I'm saying if you know the answer, try to give me. If you don't know the answer, just try. If you are not giving the question mark, but try to give it in the within 2 minutes. Okay, each question will can take the 2 minutes, right? Simmi Singh, it is very difficulty for me to speak in Hindi. That Singh, the sorry for it because it is very difficulty for me to speak in Hindi. Okay. I hope you will understand. I hope you are comfortable with the English. I think so. Good evening, Janagiram. Good evening. Now, right? Now we'll start the questions. We are from. I am from Hyderabad. Singh, I am from the Hyderabad. Right. Now we'll move to the first question. Now see the first question. Which of the following process highest energy is absorbed? Now, which of the following process highest energy is absorbed? Which of the following process highest energy is absorbed? In which of the following process the highest energy is absorbed? I hope the question is clear. Good evening, Vishnu, good evening. Guru Sai Charan is saying 4. Once again, cross check all the options. My dear friends, cross check all the options. Cross check all the options and give me the answer. Cross check all the options and give me the answer. It is not clear. Oh God. Now he is saying that in which of the following process highest energy is absorbed. Now the answer is 1. Answer is 1. No. Answer is 1. Why? Because here I know you are thinking that here this is a lithium, right? In the periodic table lithium will be here. And next year lithium, here it will get you the fluorine. Here you will get the chlorine. Here you will get the bromine. Here you will get the iodine. Now top to bottom ionization energy, that only I am explaining. Top to bottom ionization energy decreases. Clear? But when it comes to the D block element, this is a copper. Copper will be the D block element, right? Copper is a D block element. Now copper being the D block element, here D block elements are having the higher ionization energy. The answer is 1. You may think that lithium compared to the lithium is having the higher size. Compared to the lithium and the which one? Copper is having the least size. Among the 4, copper is having the least size. Due to that copper being the least size, it requires higher energy to remove the electron. Higher energy to remove the electron. Nothing will happen, my dear space prince. Don't worry. I now continue the class. Be regular to the class and clear. Now everything will be fine for you. Don't worry. I hope it is clear for you, everyone. I hope it is clear for you, everyone. I hope it is clear. Or still you are having any confusion? Right? Answer is Cu. Actually, Cu being the compared to this all, Cu is the smaller size. That's the reason the smaller ion requires a higher ionization energy to remove. Highest energy to absorb means highest energy to remove. Because here you can see Cu is converting into Cu plus. Right. Now next question. I hope it is somewhat blurred. I think so. I hope the picture is clear. Right. Now I hope it is clear. Right. Now what is asking? Now read the question and say me the answer. In the third period, the valency of an element. In the third period, the valency of an element. In the third period, the valency of an element. 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 I did. In third period, the valency of an element. I did, my dear friend, I did. Answer is 3. Answer is 4. My dear friends, once again you cross check and try to give me the correct answer. Once again, you cross check the questions carefully and try to give me the answer. My dear friend, the 3 is, my dear friend, 3 and 4 is wrong. The answer is 1. Good, good. Answer is 1. What is saying, Nana? In third period is asking, right? Third period. What are the elements? What are the elements in the third period? Third period we know that is sodium, right? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, right? And the argon, right? Now valency of an element is asking. Now sodium it is having the 1 valency, magnesium it is having the 2 because it is a 3s1, it is 3s2. Now this is 3s2, 3p1. Now this one 3p2, this one 3p3, this one 3p4, and this one is a 3p5. Clear? See, increase one by one from the 1a to 7a groups. From 1a to 7a group, it will be increased, right? Now decrease one by one from the, no, you can see here 1, 2, 3, 3, 4, 5, 6, 7, increasing one by one from the 1a to 7a. Clear? Not the answer. The answer is 1. Okay? Answer is 1. Is it clear? Right. Next. No. Next question. Next question. Right. Next question. Okay. Next question. The increasing order of electronegativity is correctly represented as. The increasing order of electronegativity is correctly represented as. Correctly represented as. The increasing order of electronegativity is correctly represented as. Answer is 1. 1. Amit Dubey saying 4. No. Answer is 1. Venkata Sai Kirtan 1. 1. Right. The answer is 1. Good. Answer is 1. Why the answer is 1? Answer is 1. Good everyone. Answer is 1. We know, right? Here these are the third period elements: phosphorus, sulfur, and the chlorine. Left to right, if we move in the periodic table, ionization energy increases. But here this phosphorus, here the nitrogen, phosphorus, arsenic, antimony, and the bismuth, right? Clear? Now top to bottom, if you move, what happens? Ionization energy decreases. Compared to the here, the ionization energy will be increases. Chlorine, sulfur, phosphorus is having the higher ionization energy. But bismuth being the top to bottom, higher size, what happens to the electronegativity? Electronegativity will be decreased. The only option we are having only here. See, chlorine, sulfur, phosphorus, and the bismuth. The answer is 1. Clear? Now, is it clear? Is it clear? Now, right. Now, what? Joshita is asking bismuth electronegativity value. Bismuth electronegativity value is almost 2. Almost 2. Approx or almost 2. 2 it is there. 2. Hi Sri Ganesh. Hi, hi. Right, right. Right. Done. Now, next one. This is your favorite question and the easy question. I hope the question is clear for you. Is asking the order of screening effect of electrons of S comma P comma D and F orbitals of the given shell of atom on its outer shell electron is. He is asking the screening effect of electrons of SPDF orbitals of a given shell of an atom on its outer shell electron. Indirectly, he is asking the shielding effect. Good, good, everyone. Janakiram, Vaishnavi, Amit Dubey, Nitya, Subhana, Venkata Sai Kirtan, Akshara, Rishita, Yashwant, Guru Sai Charan, Suraj, Chandana, Ketan, Joshita, everyone. Good, Anna. Good. See, he's asking the screening effect, right? Now, this is a nucleus. Now, the S electrons will protect the valence electron strongly. Now, next to the P electrons, next the D and F for the poor shielding, right? D and F for the poor shielding. So, the valency electron will be strongly protected by the which one? S and P electron. So, the order is S greater than P greater than D greater than F. Good Vishnu, good. Good Ajit Boxer, good. Right. Next one. The hydrogen has highest ionization energy than the alkali metals is due to. Good Vishnu, good. Now right. Hydrogen has highest ionization energy than alkali metals. It is due to. Lasya is saying 1. Ama, larger the size, lesser will be the ionization energy. Guru Sai Charan is saying no. Sri Nitya is saying 2. Joshita is saying 2. Suraj Behra is saying 2. Rishita is saying 2. Yashwant is saying 2. Good. That what? Hydrogen compared to the lithium and hydrogen, lithium is having the higher size than the hydrogen. Lithium is having the higher size than the hydrogen. Good. Good Subhana, good Akshara, good Ajit Boxer, good Sai Vaishnavi. Here, hydrogen and the lithium, if you cross check, lithium is having the higher size than the hydrogen. Alkali metals is asking, right? Hydrogen being the smaller size, what happens? Its valency electrons are strongly attracted toward the nucleus. If it is strongly attracted toward the nucleus, we require higher energy to remove this electron. So, the hydrogen has highest ionization energy than the alkali metals is due to the small size. Actually, hydrogen being the small size, so it will this valency electron of the hydrogen is strongly attracted toward the nucleus. If it is strongly attracted toward the nucleus, it requires higher energy to remove this one. Okay? Right? Because if it is having strong attraction, what it will happen? Strong attraction means what it will happen? It will be hold that electron very strongly. So if you require, it requires higher energy to remove that electron. Okay? Done. Okay, right. Next one. Decreasing order of ionization potential of the following elements. Decreasing order of ionization potential of the following elements. What is the order? Now, next one. The decreasing of the ionization potential of the following elements is. The decreasing order of the ionization potential in the following elements is. Good, good, good. Soram Sri Ganesh, good, good. Guru Sai Charan. Sai Vaishnavi, once you cross check, amma. Ketan, okay. No, 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 no. No, Ishwant, once you cross check. Once you cross check. Good, good, good. Suraj, good. Answer is 2. Venkata Sai Kirtan, good, go 2. Right, right, right. Now, good, 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 everyone, good. No, answer is 2. Right, the answer is 2. Why? Because, why the answer is 2? Because here the neon being the completely filled electronic configuration of the neon being the completely filled electronic configuration of the P6, it requires higher energy. Next to the chlorine, we know left to right, when it comes to the sodium, magnesium, aluminum. Magnesium being the completely filled of the S, and this is partially filled of the aluminum. If I remove one electron from the aluminum, very fastly it will reach to the stable electronic configuration. Then when very fastly when it is reaching to the stable electronic configuration means very less energy it will give the electron. But magnesium, if I remove one electron from it, it will, what it will happen, its stability will be lost. So it requires higher energy than compared to the sodium, aluminum and the magnesium. Then after that here the silicon. Then after that the phosphorus and the sulfur. Phosphorus we know that it is having the half field. Sulfur what it is happened? Sulfur 2p4, right? If one electron is removed from the sulfur, very fastly it will reach to the phosphorus. But phosphorus, if I remove one electron, it will reach to the instability, making the stable one unstable, require higher energy. So neon, chlorine, phosphorus, sulfur, magnesium and the aluminum. Answer is 2. Okay, my dear friends, I hope it is clear for you. I hope it is clear for you. Should I explain once again? We know, right? Fully filled, fulfilled and half-filled orbitals have high IE. Remember this one. Fully filled and half-filled orbitals are having the high IE, high ionization energy. I hope it is clear for you. Yes, right, right, right. Right, right. Right. This is the one very important question for you. I will see how many of you will give the correct answer. I will see how many of you will give the correct answer. Now, if the options and everything, if it is are not clear, you just say me. I'm ready to explain. Is the question is clear? What is the answer you are saying? Image is unclear. Array yaar. He's asking the gadolinium atomic number, electronic configuration. This one is option number 1 is xenon 4f3, here 5d something, 4f3 5d5 is 5d5 6s2. This one 4f7 5d2 6s1. This is 4f7 5d1 6s2. Answer is 3. Good everyone. Good. My dear friends, this is good actually. Now, only one thing you have to remember. Now, what you have to remember for the gadolinium GT64? Now, what you have to remember for this year, only for the 58 atomic number 58 to the 71, atomic number 58 to the 71 will belongs to F block, will belongs to the which block? F block. When this belong to the F block, only 58 atomic number will be the which one? 58 atomic number will be the cerium. Cerium electronic configuration will be 6s2 5d1 4f1, right? Next, GD gadolinium xenon 6s2 5d1 4f14, sir, 4f7. Next, lutetium Lu xenon 6s2 5d1 and 4f14. Only these three elements in the F block elements will have D1 electronic configuration. Remaining other elements will not have any D electronic configuration. Hi Rajashekar. Hi. Clear? Is it clear? Is it clear? Only these three elements will have D electronic configuration. Remaining other elements will not have any D electronic configuration. Okay, this is xenon 4f7 5d1 6s2. Now you know xenon atomic number is 54. 54 plus 7, how much? That it will be the 61. 61 plus 1 62. 62 plus 2 64, right? Hi Rajasekar. Hi. Now, right? I hope it is clear. Shall we move to the next question? Yes, answer is 3. Now next question. The electronic configuration of the four elements A, B, C, D are given below. Now, which of the following is the correct order of the increasing tendency to gain the electron? Now, electronic configurations they have given, and they are asking electronic configurations of the four elements A, B, C, D are given. Now, which of the following is correct order of the increasing tendency to gain the electron? Guru Sai Charan is saying 4. Janakiram is saying 2. Which of the following is having the highest No. Sai Vaishnav is saying 1 good. Aditya Kumar Dubey is saying 3. Nikhil Satwik is saying 2. Karthik Karthik Chandana is saying 3. Only one has said the correct answer. Among you all, the only Sai Vaishnavi has said the correct answer. Answer is which one, Anna? Why you are getting confusion? Answer is 1. Answer is 1, not 3. See, 1s2, 2s2, 2p5, this is a fluorine, right? 1s2, 2s2, 2p4, this is a oxygen. This is 4, 1s2, 2s2, 2p4. Now this is 1s2, 2s2, 2p6, 3s1, this is a sodium. And 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, this is a neon. What is asking? Among the following, which one will gain the electron? Indirectly is asking the electron gain enthalpy. Indirectly is asking the electron gain enthalpy. We know here left to right, electron affinity will be increased. So among the fluorine and the oxygen, if you cross check, fluorine will have the higher electron gain enthalpy, we know, fluorine. Then after that, oxygen, right? Left to right, electron affinity will be increases. Among the fluorine and oxygen, fluorine will have the higher electron affinity. So the answer is D. Then after the B. But here the neon will not take the electron only. Neon will not take the electron only because already its shell is completely filled. Neon, it is having which of the following is having the increasing tendency to gain the electron. Which one will readily gain the electron is asking. Fluorine will readily gain the electron. Then after the oxygen. Then after that in the sodium, but neon it is not having a chance to take the electron only. All its shell is completely filled. Right? So D first, then after B, then after C, and the last is A. Last is A. Okay, many of the students have got confused between D and A. No, actually the first fluorine will be gain the electron very fastly than the sodium, because the sodium it is having the less electron, its nuclear charge is somewhat less, but fluorine being the what top to bottom also, you can think like that also, top to bottom also ionization, sorry, electron affinity will be decreased, but third period elements are having the higher electron affinity than the second period elements. That already we have discussed very clearly. I hope it is clear for you. Still you are having any confusion or should I explain? Hello Vishal Raj, good evening. Now be concentrate to the class, okay? My dear friend, be concentrate to the class. If you are having any concerns and if you are having any doubts, you can ask. Is it clear for everyone? Is this question is clear for everyone? Or still you are having any confusion or any misconceptions or any confusions you are having? I hope it is clear for everyone. Hi, Kola Ranit. Good evening. Right. Okay, we are moving to the next question. Now we are moving to the next question. That's what I'm saying. Top to bottom electron affinity decreases, right? Good evening, Vishal Raj. I said, top to bottom electron affinity decreases. Then top to bottom electron affinity decreases means compared to the fluorine and oxygen, sodium is having less electron gain tendency, right? Right. The ion having maximum ionization energy. The ion having maximum ionization energy. The ion having maximum ionization energy. Which one is having the maximum ionization energy? 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 Three. Guru Sai Charan, once you cross check all the options. Once you cross check all the options. 2. Ranit said 2. And who? Next one. Win Joshita is saying 4. Kola Ranit saying 2 good. Samata. Samata is saying 1. Ajit Vaksar is saying 1. Ketan is saying 2. Srinitya is saying 1. My God. My dear friends, the answer is 2. Answer is 2. See Nana, this is F minus, right? This is F minus. Fluorine neutral atom, already it is having a one extra electron. Fluorine, you can see this is a fluorine. Normally fluorine contain 9 electrons and it contain 9 protons. 9 protons and the 9 electrons in it. But one extra 1 electron has added means 9 protons for the fluorine, 9 protons for the fluorine and 10 electrons means 1 electron is unbalanced in the fluorine. So very fastly it will be given, right? Why it will take the maximum energy? To get the stability or to, even though it is having the neon electronic configuration, even though it is getting the neon electronic configuration, but that electron is get repelling. But here the Mg plus 2, you can see Mg it is having the 12 protons and 10 electrons. 12 protons means this nucleus, this valency electrons are strongly attracted towards the nucleus. When they strongly attracted towards the nucleus, when they strongly attracted towards the nucleus, it requires higher energy to remove compared to the Mg plus 2. Here the nucleus charge is 1 because it contains 11 protons and 10 electrons. Here one proton is unbalanced. Here the 2 protons are unbalanced. So very strongly it will pull the electrons towards itself. Very strongly valency electrons are pulling to the nucleus means we require higher energy to remove. This O minus 2, 2 electrons are unbalanced means easily it is want to ready to give. Okay? Good, good, good. Good, Sri Ganesh, good, good, good. So the answer is 2, not 1. Don't get confused by seeing the fluorine. Already the fluorine it is having the minus charge. Minus indicates that we know, right? Minus indicates that what? Gaining of electron. Minus indicates that gaining of electron. So don't get confused by seeing giving the fluorine by giving that one. Right. Now, next one. The ionic radius of N minus 3, O minus 2 and F minus respectively are. The ionic radius in angstrom of N minus 3, O minus 2 and F minus are respectively. The ionic radius in angstrom N minus 3, O minus 2 and F minus are respectively. The ionic radius N minus 3, O minus 2, F minus are respectively. Answer is 1. See the options carefully and try to give me the answer. See the options carefully, try to give me the answer. My dear friends, you are getting confusion in the options. Sai Vaishnavi and the Ketan, Arjuna Ketan, once you cross check, you are getting confusion in the options, I think so. Now you see, these 3 are the isoelectronic, right? These 3 are the isoelectronic. N minus 3, O minus 2, F minus. Now isoelectronic species means now one which is having the higher negative charge will have the higher size. N minus 3 is having the higher size, right? N minus 3 is having the higher size. If the n minus 3 is having the higher size means among the 1.3, 1.4, 1.7, which is having higher size? 1.4 is having the higher, 1.7 is having the higher. Then 1.4, last one will be the 1.36. So the option number 3 is correct, right? 1.7, 1.4, 1.3. No, answer is 3. He is asking the ionic radius or respectively is asking 1.71, 1.40, 1.31. Clear? Is it clear? I hope you are confused between the options. Yes, yes, good, good. Yashwant, you have said the good. Joshita also said the correct. Good, good. And which one? Subhana also said the correct. Okay, okay. Right, right. Okay, done, done. Next one. Which of the following options contain isoelectronic species? Which of the following 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 contain isoelectronic species? Two, two, one, two, one, two, three, two, two, two. See, this is the isoelectronic, right? Here, this is contain 18 electrons. K plus contain 18, chlorine contain 18, S minus 2 contain 18. All are containing 18 electrons, right? All are containing 18 electrons. But here the 18, this is 18, this is 10, this is 7. This is not isoelectronic. Here this is 18, this is 2, this is 10, not electronic. This is 18, this is which one? Again, this one reached to the noble gas, right? Now this is 36. Now this is a 54. But the only the isoelectronic same number of electrons are only in the option number 2. Good everyone, good, 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 good. The first ionization enthalpies of is asking among the sodium, magnesium, aluminum and silicon. First ionization enthalpies is asking. First ionization enthalpies are. First ionization enthalpies. First ionization enthalpies order. Okay. First ionization enthalpies order. Ranit is saying 2. My dear friends, he is asking the which is having the highest electron gain enthalpy. My dear friends, left to right ionization enthalpy increases. So size decreases, ionization energy increases. Left to right size decreases. So ionization energy should be increased. Sodium should not, will never and ever will have the higher ionization energy than the magnesium. No. First ionization enthalpy for the sodium, magnesium, aluminum. My dear friends, why you are getting confusion? I was not at all understanding. The answer is 1. The answer is 1. Sodium, magnesium, aluminum, silicon. Sodium it contains 3s1, magnesium it contains 3s2, aluminum it contains 3p1, silicon it contains 3p2. Then compared to the sodium and the magnesium, magnesium due to the completely filled of s electrons, it requires higher energy than the sodium. So next aluminum, by the loss of this one electron, very fastly it will reach to the magnesium. So that's the reason aluminum will readily give the electron than the magnesium. Then the magnesium it will not readily lose the electron, so the magnesium will have the higher ionization energy. Then after aluminum and silicon, silicon due to the presence of now higher nuclear charge, it will have the higher ionization energy. So the option 1 is correct. Why the option 3? How you are thinking that the option 3? Now we know, right? Among the aluminum and among the magnesium, just now I said due to the presence of the completely filled s electrons, magnesium is having the higher ionization energy than the aluminum. So the option 1 is correct, right? My dear friends, see the options carefully. See the options carefully and try to give the answer. Okay? Now, this is one good statement based question. Try to give me the answer. Okay. Right. Now, what is the answer for this one? This question? What is the answer for this question? What is the answer for this question? Ranit is saying it is 4. No. No, my dear friends, once you cross check once again. No. Answer is not the 4. Answer is not the 4. Here, read the question carefully. O minus to form the oxygen atom require the first electron gain enthalpy is always exothermic. We know. First electron gain enthalpy is always exothermic. That's the reason energy is releasing. Second electron gain enthalpy is always endothermic. Why is asking? Why? What is the option? It will be correct. Oxygen is a more electronegative. The process of O minus 2 in the gaseous phase is unfavorable even though O minus 2 is isoelectronic with the neon. It is due to the fact of the answer is 3. Answer is 3. Not 1. No, the answer is 3. Answer is 3. Because this O minus 2, why you are getting confusion, Anna? Here, oxygen contain 8 protons and 8, how many 8 protons and the 8 electrons in it? Here 1, 2, 3, 4, 5, 6, 7, 8. And one extra electron if you added, already 8 electrons are balancing with the 8 protons. But this one electron which has added in the first, it is not having any chance to form the bond with the proton. It is searching for the proton to get balance. Again, another electron, if it is come to form a or want to enter into that orbit, already this electron is only not getting the any proton to get balance. Why it will allow this another electrons to form a bond? That electron repulsion outweighs the stability gained by achieving the noble gas electron economy. Even though if you gain the electron also, these electrons are not getting stability. Then when these electrons are not getting stability means it will whatever, even though it is achieved the noble gas electronic configuration also, not at all required any, there is no reason, right? So the answer is 3. Next question. Now what is saying? The positive ion Positive ion. No. Now what is the answer for this question? My dear friends, we have did only the 15 questions. Now almost the time we have taken the 50 minutes we have taken the for 50 minutes we have taken the 15 questions. So try to be speed up. We are having the n number of questions. Hi Astrid, hi. Now what is the answer for this one? Positive ions will be wider, larger than the parent atoms. Next the nuclear charge pulls them closer. Answer is 3. No. Once you cross check, my dear friend, not the answer is 3. Not the answer is 3. Not the answer is 3, Nana. What is saying the positive ions will be larger than the parent atom? If you see, answer is 4. Are you know, right? This is sodium. This is sodium and the Na plus. Or if you cross check the sodium and Na plus, what I said here, the sodium is neutral and the sodium plus is having the positive, right? Now positive ion means higher nuclear charge. Higher nuclear charge means lesser size, right? So positive ion will be larger than the parent atom. This is sodium is a parent atom. If I remove one electron, this is a positive ion. Positive ion higher nuclear charge means lesser size, right? This one is having the higher size and the nuclear charge pulls them closer. That is true. But for statement 1 is false and the statement 2 is a true, right? So the option 4 is correct. Option 4 is correct. No, the parent atom is having the higher size than the anion. But parent here you can see. If suppose if they have given, let's suppose Br minus Br and Br plus. This is correct. Parent atom is having the lesser size for the anion, not for the positive cation or positive ion. For negative ion, now, right? The answer is 2. So answer is 4. Now asterisk, whatever the, my dear friend, whatever the concerns you are having, we'll discuss in our live, because this is our first year's lives, right? So I cannot be more focused on you. 9:30 we'll start our live. There we will discuss, my dear friends. But how much you are able to do, you can do. Whether it is a GOC or whether it is a hydrocarbons or whether it is a allyl alkyl or alcohol phenol ether. But mainly you just focus and try to complete the GOC and the hydrocarbons first, then only you enter into the second year organic. Without knowing the GOC and the hydrocarbons, my dear friend, don't enter into the second year organic. Okay. The remaining, if you are having any concerns, we will discuss in our second year live. Okay, my dear friend. Right. Next one. I hope it is clear for you, this picture. My dear friend. Okay. What is asking? Is asking the electronic configuration of the element. You can see here. Now the electronic configuration of the element, which is just above to the atomic number 43. My dear friend, actually about my outfits, many of the students they are asking. Actually the outfit, this outfit for the reason is this one. I went to the one village of my friend's village I went, while actually I forgot to take my dress while we are going to my friend's home. It has become the late night. I was stayed over there. From there directly I came to the college. While coming, when I took the bath, I brought the new dress over there actually. That is the reason for this my outfit, but there is no any other else. Okay. Actually, at the morning, today morning itself, I asked my friend to bring the new dress, and he is in his city or in his home near to that one dress shop is there. There the morning I brought this one and I wore and I came. That's it. That is the reason for it. Nothing else. Now, right? Now what is the answer? 43, right? 43 means where it will be there? Now 43 will be, here we know 43 will comes under the 19 to here 36. Next one will be the 37 to 54. 43, 37 and the 38 will be yes, and the 39, 40, 41, 42, 43. Right? This is the third group, fourth group, fifth group, sixth group and the seventh group. Right? Seventh group. Above to the seventh group. Now we know this is a scandium, titanium, vanadium, chromium and the manganese. Indirectly is asking the manganese electronic configuration. Manganese electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Where is the 3d5? 4s2, 3d5, 4s2, 3d5. Now the 4s2, 3d5 is option number 1. Option number 1. Indirectly is asking the manganese. Right? Option number 1. The element with atomic number 35, 53, 85 are all. Okay, fine, fine. Thank you for it. నేను రీజన్ చెప్తున్నా దానికి. That outfit ki reason నేను చెప్తున్నా. Okay, thank you for your compliment. Now, right. Next one. The element with atomic number 35, 53, 85 are all. My dear friends, be fast. Answer is 2. Answer is 2. Good, good, good. Joshita Joshita had said, Janakiram has said, Sri Ganesh is saying, Ramulu, Yashwant, you have said correct only. Now, next one, Akshara is saying correct only. Rishita is saying correct. Now answer is halogens. We know, right? This is 2, helium, neon, 10, argon, 18, krypton, 36, xenon, 54, 35, 53, 85. Means here the radon will be the 86. Now we know, right? Now you see, here the 9 will be there, here the 17 will be there, here the 35 will be there, here the which one? 53 will be there, here the 80, what? 85 will be there. Here the 85 will be there. 35, 53, 85 will comes under the halogens, right? 35, 53, 85 will comes under the halogens, right? Which of the following is a correct order of the size of the given species? Now, correct order of the size of the given species. Now, try to say me this one. What is the answer for it? What is the answer for this question? What is the answer for this question? What is the answer for this question? Answer is 4. Good, good, good. Everyone, good, good. 4. Just now I said, right? If any parent atom, if you take iodine, now iodine it is having the I minus and it is having the I plus. Now here the which one? Protons are 53, electrons, protons are 53, electrons are 54. Here the protons are 53, electrons are also 53. Iodine, here the protons are 53, electrons are 52. Here the high nuclear charge, less size. Here the electron, one repulsion, Due to that, it is having the higher size than the parent atom. This is a parent atom. Now it is having the higher size than the IPS. The answer is 4. Good. Good everyone. Good, good, good. Next. An element having the electronic configuration of 4f7, 5d1, 6s2, it belongs to the block of the periodic table. Good everyone. Good, good, good. It will belongs to the which block? My dear friend, try to give me the answer correctly. An element has the electronic configuration 4f7, 5d1, 6s2. It belongs to the good, good, good. Yes, it will belongs to the F block. Yes. See, Nana, here xenon is 54, right? Xenon electronic configuration, xenon atomic number is 54. After the 54, 7 plus 1, 8. Then it will become 62, 62 plus 2. This is 64 electrons are there in this electronic configuration. Now already I said 58 to 71. 58 to 71 atomic number. 58 to 71 atomic number elements will be belong to the F block. So the answer is 4. Answer is 4. Here xenon 54 kada. This is element is gadolinium GD 54 plus 8. So the electrons having of the 68. Now atomic number 58 to 71 will be belongs to the F block, and the 90 to 103 is also belong to the F block. These are the actinides. These are the lanthanides. Already they have given right here, Nana. Just by seeing here itself also you can say. Why to get confused? Already they have given the 4f7. Any electrons to be filled. Now fluorine should have the, sorry, F block should have the 14 lakh, but here having only 7. So directly you can know. By seeing itself you can say the answer. There is not at all having any confusion here. ikkada ichchadu kada 4f7. Directly you can answer. The outermost electronic configuration of the most electronegative element. Yes, good, good, good. Next one. The outermost electronic configuration of the most electronegative element is. Vaishnavi is saying 4. No, once you cross check, the outermost electronic configuration of the most electronegative element is. The answer is 3. This is neon. Neon is not the more electronegative. Already I said this is oxygen, this is nitrogen, this is fluorine. Already I said you. Now total periodic table, fluorine is the highest electronegative element. Fluorine is the highest electronegative elements and its value En is 4. These are stable. Neon is a stable. It will not take the electron and it will not give the electron. This is a neon, it is a stable, its octet is completed, it will not take the electron, it will not give the electron. But fluorine being the more electronegative, it will readily take the electron and its electron negativity value is 4. Blindly believe, entire periodic table, the fluorine is a high electronegative element. Right? Right. The element which has second highest ionization energy. Is asking second highest ionization energy. Which of the following is having the second highest ionization energy? Second is asking. Already I explained. Second if is asking means cross check the electrons of the first one. Yes. Good, good, good. See, Nana, first ionization energy means lithium. If I remove the one electron, IE1, IE1 of lithium, IE1 of lithium will reach to the helium. Now, IE1 of the beryllium reach to the lithium. IE1 of the potassium reach to the argon. IE1 of the IE1 of the boron will reach to the beryllium. Now, second ionization energy is asking. Now, among these we have to cross check. Among these, helium and the argon, down the group, what happens? IE will be decreased. So, among the helium and the argon, helium will have the higher ionization energy and it has reached to the noble gas. This is the lithium and it is a beryllium. So, the helium, in this helium, to remove the electron, we require higher energy. So, the one is correct. Helium is correct, right? Sorry, lithium is correct. The second highest ionization energy is for the lithium. So, the answer is 1. Second is asking. Second ionization energy. Second highest ionization energy. Second highest ionization energy will be this one. Right? One. This was somewhat tricky question. See the options carefully and try to give me the answer. See the options carefully and try to give me the answer. See the options carefully and try to give me the answer. Okay? See the options carefully and try to give me the answer. Answer is 3. Good, Ashwant. Good. Answer is 3. What is saying, Amma? Here indirectly is saying that addition of electron to the atom, energy releases. X minus indicating that energy releases. Addition of electron means first electron gain enthalpy is negative, is saying. Yes, first electron gain enthalpy delta H is negative. But is asking in which process require the plus kilojoules of energy, means which process among the given 4, which one is ionization energy. Indirectly is asking in which case electron has been removed, is asking. You see, this is A minus 2. From this A minus 2 we have removed the 1 electron. Then here we have added the 1 electron. We have added the electron means delta H is negative, right? Here also, what from the positive we have added the electron, delta H is negative, means minus x kilojoule. Here also minus x kilojoule. Here delta H is x, but here from the minus 2 removing the 1 electron. See, here the A minus 2 means 2 electrons are unbalanced. Here A minus means 1 electron is unbalanced. 2 electrons unbalanced means very fastly it will give. Now here A minus. From here, the A minus, it requires higher energy. In the which of the following as the enthalpy is equal to x joule? Which one having the x joule? So the answer is 3. Right? Right. Next one. The sudden large jump between the value of second and third ionization energy of an element would be associated with the electronic configuration. Second and third. Is asking second and third ionization energies of the element associated with the electronic configuration. Second and third. Is not asking the first one. Second and third difference. Sudden large jump between the second IE and the third IE. second IE and the third IE. Second IE and third IE. Yes, good. Answer is 4. Answer is 4. See, here from here we can remove the 2. 2 electrons, second ionization energy done. Third ionization energy has reached to the which one? Neon. Neon, for the third ionization energy, neon required higher energy. Neon require higher energy to remove the electron, right? See, 2 electrons can be easily removed, but last electron can be neon. From the neon, it requires higher energy. Now we can see here if you consider for the A, if you go it for the A, see, first ionization energy can be removed easily, but second ionization energy is coming for the neon, right? Second ionization energy should be drastic change for the option number 1. ikkadiki pote here 1, here 2, 3, this is not at all having any change. Here 2 and 3, there is also not having any change. So the option number 4 is correct. Why you are getting confusion? There is no any how to identify the ionization energy. How to identify the ionization energy? There is no need of identifying any ionization energy. Ionization energy removed. Just remember this one. What are the key points to remember? Now, left to right, ionization energy increases. Only this one. Lithium. Next one here the boron. Here the beryllium, carbon, oxygen, nitrogen, and fluorine, and the neon. This is for the second period. Third period, sodium, aluminium, next magnesium, this is silicon, this is sulfur, and this is a which one? Phosphorus, this is a chlorine, and this is a argon. Just you remember this one. That's it. This is the ionization energy order. What is the change here we are getting? Only the change we are having here due to the s orbital completely filled. Here the change we are getting due to the off field. Due to the off field. That's it. That's it. Right. Which of the following does not represent the correct mentioned property? Which of the following option? Ashrita, I hope it is clear for you. I hope it is clear for you. Now I hope it is clear for you. Now what is the answer for this one? Answer is 1. He is asking does not represent correct. Does not represent the correct mentioned property. Does not represent the correct mentioned property. Answer is 3. See, here the answer should come lithium, boron, and the beryllium. But here they have given the beryllium and boron. So the answer is 3. This is correct only. O minus 2 will have the higher size. O minus, then the O. This is correct only. Higher the nuclear charge, higher the negative charge, higher is the size I said. This is also correct only. This is also correct. This is also correct. Now electronegativity, top to bottom, fluorine, chlorine, bromine, iodine. Top to bottom, what happens? Size decreases, electronegativity size increases, electronegativity decreases. So the only answer is 3. Actually, ionization enthalpy should be in this manner, right? Answer is 3. Yes. Answer is 3. This should be the wrong. Right. Okay, right. Next one. What he has given? The IUPAC of an element of electronic configuration. IUPAC they have given this one. and they are asking the which one? They are asking the IUPAC for this atomic number. Electronic configuration they have given. They are asking the IUPAC. They are asking the IUPAC. What is the answer? This is radon, right? Yes, good. Radon, right? Radon is 86. 86 plus 14, it is 100. 100 plus 1, 101. 101 plus 2, it is indirectly 103. For the 103 atom, IUPAC is asking. 1 is un, 0 is nil, and 3 is tri, and IUM. Unnil trium. Option number 4. Unnil trium. Answer is 4. Unnil trium. Unnil trium. Indirectly we can directly you can see 61 4F 61 SS2. Unnil trium. Answer is unnil trium. You have to be very careful with this one. Right? We'll move to the next question. Here what is given? Electronic configuration they have given. Delta HF means indirectly is asking ionization energy. Indirectly is asking the ionization energy. Now match the following. Match the following. Which one requires the higher ionization energy? Which requires higher ionization energy? Which requires higher ionization energy? Answer is 4. Saying that answer is 4. Oh, answer is 4. Answer is 2, 3. See, this is nothing but beryllium. This is nothing but oxygen. This is nothing but nitrogen. This is nothing but boron. Now, here arrange them in the increasing order. C is first. Then after the C, B is second. Then after that, A. Then after that, D. So C should have the highest ionization energy. C should have the highest ionization energy. In which case the C is having the highest? In the 4. C should be 4. Then A should be, C should be 1402. B should be 1314. A should be 8999. And D should be 801. Now you can see A is 2. A is 2. B is 3. Yes. B is 3. Correct. Next. C should be 4. C should be 4. So the answer is 4. Answer is 4. Good, good everyone. Answer is 4. Answer is 4. Answer is 4. Right? Right. Next one. The 5 successive ionization enthalpies of the elements are 800, 2427, 3658, 25,000 and this one. Now, the number of valency electrons in the element is within 10 minutes. Only 1, 2, 3, 4, 5. Only 5 questions are there. Just by 8:30 or 8:35 I will end. Only 5 questions left. Only 5 questions. Only the 5 questions are left. By 8:30 or 8:35 I will end. Only 5 questions are left. Try to give me the answer, Nana. What I have to explain? This is the order actually. This is the order. Ionization energy order. Which one? Nitrogen greater than, oxygen greater than, boron greater than, beryllium. Among this one, give the higher ionization energy. That's it. Now, answer is 1. He is asking 800, 42, 368 and drastic change on this one. Answer is right. No. How come 5? No. The answer is 3 only. Yes. Here if you take this as the aluminium, for this aluminium, if you remove the one electron, it will reach to the beryllium. Beryllium itself, it requires the higher energy. From the beryllium, not beryllium, it will reach to the magnesium. From the magnesium, this is first IE. From this first IE, it will reach to the which one? Magnesium, it will reach to the sodium. This is second IE. Now, first IE, now it will reach to the magnesium. From the magnesium, it required higher energy. This is second ionization energy, and this will reach to the third. Third from we require only 3658. But when it has reached to the neon, it required 25. So the answer is 1. No, the answer is 1. Only 3 valency electrons. Nothing but aluminium. Nothing but 3. Right? See, Nana, here if you take the valency electrons are 4, now the valency electrons are 3. If these valency electrons are 3, now you can see. Here you can see 800, right? 3 electrons, aluminium if you take, for the aluminium, if I remove onto electron, 1 electron, it requires 800 kilojoules. It will reach to the which one? Magnesium. Magnesium, due to the half completely filled, it requires how much energy? It requires the 2427. This is second I. From this, if I remove 1 electron, it will reach to the sodium. Sodium require nominal 3658. From this, after removing the electron from the sodium, it will reach to the neon. Neon require noble gas, right? It require higher drastic change, you can see. From this year to year, almost a drastic change, it is noble gas, right? Noble gas. Then after that, here if you remove, it will give to the fluorine. Fluorine require higher energy. So it will match with the only option number 3. Next, the highest negative electron gain enthalpy between the fluorine, chlorine, bromine, iodine. In the negative is asking. In the negative, aluminium is having the only 3 valency electrons. How? It is neon, 3s2, 3p1. After 3 electrons, if you remove, 4th ionization is neon only. It requires higher ionization energy. That's it. Now, here is asking the electron gain enthalpy for the fluorine, chlorine, bromine, iodine, respectively R. Nothing, fluorine, chlorine, bromine, iodine. He is asking electron affinity order, electron gain enthalpy order. Which is having the highest electron gain enthalpy in this fluorine, chlorine, bromine, iodine? Which is having the higher electron gain enthalpy? Now, fluorine, chlorine, it should have the highest negative electron gain enthalpy. Among the given option, which is having the highest negative electron gain enthalpy? Minus 349 should be for the chlorine. Minus 349 should be for the which one? Chlorine. Fluorine, it should have the minus 333. and bromine it should have the minus 325, and iodine it should have the minus 296. So fluorine should have the 333, then after 349, 325. So option number 4 is correct. Option number 4 is correct. Option number 4 is correct. Is it clear? Is it clear? Is it clear, everyone? Next, within the each pair of the elements fluorine, chlorine, sulfur, selenium, and the lithium, sodium, the respective the element that release the more energy upon electron gain is. Indirectly is asking the which is having the highest electron gain enthalpy. Indirectly is asking the which is having the highest electron gain enthalpy. Indirectly is asking the which is having the highest electron gain enthalpy. Answer is 4. Which among the following is having the highest electron gain enthalpy? The first is the fluorine. Within the each pair, fluorine and chlorine, chlorine, selenium and sulfur, sulfur, lithium and sodium, lithium. So the answer is 1. Answer is 1. The answer is 1. See, fluorine and the chlorine, we know already I explained you. Among the second period elements and the third period elements, third period is having high electron affinity. So among the fluorine and chlorine, chlorine. Now sulfur and the selenium, sulfur. Then lithium and the sodium, lithium. So the answer is 1. The answer is 1. Right. Which of the following is not the endothermic in nature? He is asking which of the following is not endothermic in nature. Endothermic in nature. Which of the following is not endothermic in nature? Don't know. First one, this one we are adding the electron. This is delta H is positive because already it's completely filled. Neon electronic configuration is completely filled. If we add the electron, positive. Hydrogen, by gaining the electron, it is reaching to the noble gas electronic configuration. Delta H is negative. Sodium, we have removed the electron. Delta H is positive. Now oxygen, another electron we are having. Second electron gain enthalpy is always positive. Which of the following is not the endo means? Option number 2. Option number 2. No. Option number 2. Hydrogen, we are adding the neutral gaseous atom, we are adding the electron, delta H is negative. First electron gain enthalpy negative. In all the cases, delta H positive. No, option number 2. Option number 2. Option number 2. Right. Now the correct order of electron gain enthalpy. This is one type of the exception we have. We know, right? This is actually directly I was saying. This is sulfur. For the 16th group elements, now the electron gain enthalpy will be this manner that we have to remember. This is one having which we are not having any reason. Okay. Now the very last question and very important question. Only the last 2 questions are there. Only the last 2 questions are there. Now I was going to end after this one. This is very important. Now say me the answer for this question. What is the answer for this question? What is asking? Acidic, basic and amphoteric oxides respectively. Acidic oxide, basic oxide and amphoteric oxide. The morning itself I explained very clearly. Acidic oxide, basic oxide and amphoteric oxide respectively. Acidic oxide, basic oxide and the amphoteric oxide respectively. Acidic oxide, basic oxide, amphoteric oxide respectively. Acidic oxide, basic oxide, amphoteric oxide respectively. Acidic oxide, basic oxide and amphoteric oxide respectively. Acidic oxide, basic oxide, amphoteric oxide respectively. The answer is 4. Answer is 4. This is acidic oxide, N2O3. Why the N2O3? This is 2x plus 3 minus 2 is equal to 0. This is minus 3, x is equal to plus 3. X is equal to plus 3. N2O3. This is a N2O3 is a which one? Acidic oxide. Lithium oxide. This one is a basic oxide. Now Al2O3 is a amphoteric. Al2O3 is a amphoteric. So the option is 4. Right. This is very important. Which of the following pair of the oxides is acidic in nature? Both should be in the acidic in nature. Which of the following should be? Both are in acidic in nature. What is the answer? What is the answer? Which of the following is both acidic in nature? For this question, this is very important. Which of the following is acidic in nature? 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 Both should be acidic in nature. Both should be acidic in nature. Which of the following should be both? No, this is neutral oxide. N2O is a neutral oxide. It is not the acidic. This is neutral oxide. These two are the acidic oxide. This is basic oxide. This is basic oxide. Now this is acidic oxide. Now here the B2O3 and SiO2 are the acidic oxides. So the option number 3 is correct. Option number 3. Option number 3 is correct. Option number 3 is correct. Now, my dear friends, I want to ask you one question. By that, we can end our session. Last question I will ask and I will end our session. Now, what is our question that we are having? The only question that we are having is now here 1s1, 1s2, 2s2, 2p2, 1s2, 2s2, 2p6, 1s2, 2s2, 3s1. Lowest IE in this configuration. Lowest IE in this configurations. Lowest IE among the A, B, C, D. Lowest ionization energy. Lowest ionization energy. Lowest ionization energy. No, this is hydrogen. This is hydrogen, my dear friend. Hydrogen. Hydrogen is having the highest ionization energy. No, A is not the answer. The answer is B. Answer is B. Answer is B. No. This is hydrogen. Hydrogen is having the higher ionization energy, my dear friends. Don't get confused. Hydrogen is having the higher ionization energy. Answer is B. Answer is B. Next, one last question I want to ask you. Now, atomic number 38 belongs to. Atomic number 38 belongs to. Atomic number 38 belongs to. Atomic number 38 belongs to group, period, and block. Group, period, and block. Group, period, and the block. Atomic number 38 belongs to the group, period and the block. Atomic number 38 belongs to the group, period and the block. No, atomic number 38, Nana, atomic number 38. Here you know, right? 34, 34, 36 will be for the P. 37 and the 38. 37 and the 38. 38 is S. Period is which one? Here it is a fourth period. 2, 10, 18, 36, 54. Here the 37 to 54 will be comes under the which period? Fifth period, right? This is fifth period and the group number is 2. Fifth period, group number 2, block is S. Good, good, everyone, good. Next one last question. One last question I will ask you and I will end. Now, next one. Here the one electronic configuration we have got, and that X element in X plus 3 state. What is the atomic number of this one? Atomic number of this one. Here the electronic configuration of that X when it has reached to the X plus 3, what is the atomic number of that X? In the X plus 3 electronic configuration is this one. Clear? What is the atomic number of the X? What is the atomic number of the X? What is the atomic number of the X? Hey, my dear friend, this is argon. This is the argon. How come 58? Argon itself it is 18. Argon itself it is having 18. How come it will go to the 58? ఏమంటున్నాడు? No. See, it is that is atomic number 25. If the atomic number is 25, that is 4s2 3d5. From the manganese, if you remove the 3 electron, 2 electrons should be removed from here, 1 electron from here. So the atomic number is 25. Good. No. Atomic number is 25. He is saying X element in the plus 3 oxidation state, it is having the electronic configuration, this one. Ar 3d4. Actually, manganese, after removing of the 3 electrons, it will reach to this electronic configuration. No. Answer is Mn plus 3. Atomic number is 25. Answer is 25. No. Answer is 25, my dear friends. Don't get confused. Right. By this, I was ending the live, Nana. Now, all the best for the tomorrow's exam. This is manganese. Manganese electronic configuration is 4s2 3d5. If you remove the 3 electrons, it will reach to the argon 3d4. Argon 3d4. Right. I was ending the live here. The remaining, if you are having any concerns and all, we'll see you tomorrow. I hope you will do well in the tomorrow's exam. Right. All the best. Okay. I was ending the live. Okay. Bye. Everyone, be prepared to the other 2 subjects also and balance all the 3 subjects, because to get the rank, all the 3 subjects should be equally balanced, right? Okay, good. Bye everyone, good night. Okay, balance the 3 subjects, Anna. 3 subjects you have to balance: maths, physics and the chemistry. Okay, then only you will get the good percentile. Right, bye. Bye Akshara, bye Ajay Kumar, bye Gautam, bye Vishal, bye Joshita, bye Gautam Reddy, bye Suraj, Arjuna, bye Ashrita, bye Lasya. Right.